Okay, here's problem number 16. The velocity of a particle at time t is given by this equation. Write down the velocity of the particle when t equals 0. So v of 0 is going to be equal to 2 times 0 plus cosine of 2 times 0. So the velocity at 0 is going to be equal to, well, 2 times 0 is just 0. Cosine of 2 times 0, that's cosine of 0. So what is cosine of 0? Think about my unit circle. 0 is right here. That's 1 comma 0. So the cosine is 1. So velocity at time 0 is going to be equal to 1. So the answer is going to be 1 meter per second. That's going to be my velocity. When t equals k, the acceleration is 0. Show that k is equal to pi over 4. So what we're going to do is we need to take the derivative of velocity. The derivative of velocity gives the acceleration. So acceleration is equal to the derivative of velocity. So I have velocity is equal to 2t plus cosine of 2t. If I take the derivative of that, I get 2. The derivative of cosine is a negative sign, so I'm going to put in my negative sign of 2t, but I have to use the chain rule because there's something happening in here. So I need to multiply by the derivative of 2t, which is 2. So here is my acceleration. And I want to know when is the acceleration 0. So I'm going to have 0 is equal to 2 minus 2 times sine of 2t. Thank you very much. I'm going to move my 2 sine 2t to the left-hand side. And now I'm going to divide both sides by 2. So sine of 2t is equal to 1. So I'm going to ignore the fact that this says 2t. I'm just going to think of it as theta. So sine of theta is equal to 1. So on my unit circle, where does sine equal 1? That'll be right here at the top. That's 0, 1. So that's pi over 2. So sine of pi over 2 is equal to 1. So theta is equal to pi over 2. But it's not theta that I'm solving for. It's 2t. Theta is equal to 2t. So now that I know that the angle is pi over 2, I can say that 2t is equal to pi over 2. Divide both sides by 2. And I get t is equal to pi over 4. So I've shown that k is equal to pi over 4. Oh, sorry, t is equal to k, so therefore k is equal to pi over 4. What's that? Okay, find the exact velocity when time is pi over 4. So again, velocity, I'm going back to my velocity function. So my velocity is 2t plus cosine of 2t. I'm going to substitute in pi over 4. So velocity is 2 times pi over 4 plus cosine of 2 times pi over 4. 2 times pi over 4, that's just equal to pi over 2. And then over here, I'm going to have cosine again of pi over 2. Pi over 2, looking at my unit circle, the cosine is 0, so this just equals 0. So I have pi over 2 plus 0, which is just equal to pi over 2. So the exact velocity is pi over 2, and that would be, is it meters per second? Yes, meters per second would be my exact velocity. Okay, now, when time is less than pi over 4, the gradient is greater than 0, so it's positive, okay? The derivative is positive, it's greater than 0, so that means I have a positive slope. So I'm going to have a positive slope before pi over 4. Okay, so we're looking at our domain is from 0 to 2, so I'm going to be sketching a graph. Our domain is from 0 to 2, so here's 0. I'll put 2 over here. Pi over 4. Pi is 3, so pi over 4 is probably maybe around here. So it says when time is less than pi over 4, I have a positive slope. And, oh, I know that at time 0, I'm at 1. So I'm going to put a 1 on here. I know that my speed is 1. So I'm going to be starting at 1. And I'm going to have a positive slope up to here. But then, let's see, after time pi over 4, my slope is also positive. So I have positive slope and a positive slope, but I know that the acceleration is 0. The acceleration, the second derivative is equal to 0 at pi over 4. So that means pi over 4 is a point of inflection. So it's a point of inflection. And usually that means we're changing direction, but no, it means we're still changing concavity. So we're going to be changing concavity at pi over 4. So I am going to go like this, and then I have to change concavity. I have to have a positive slope, change of concavity, positive slope. So that is the little sketch that I can make. I know I need to have a positive slope, I need to have a change of concavity, and a positive slope. Let's see, did I miss anything else? I know the exact velocity at pi over 4 is pi over 2, so this is going to be pi over 2, it's going to be right there. Okay, hold on a second. I'm filming.